Alright, hello geometry. So today we're taking a look at some more congruent triangles, and the reason we're not moving on to the next section yet is because the next section is a lot of proofs that were not going to be a lot of fun to go through over a video, for me or for you. So we're taking a closer look at some things that we're going to be using to prove that triangles are congruent, but we're not doing the proof part yet. So today we're just looking at what are these different postulates and theorems and how are we going to use them, but we're not going to be writing proofs yet because that would be a pain in the neck to go through via video. We'll wait till we get back for that. Okay, so what we're looking at is 4 different postulates/theorems that we can use to prove that triangles are congruent. So the first one is that triangles are congruent if we have 3 pairs of corresponding sides that are congruent. So if I know that these sides are congruent, and these sides are congruent, and these sides are congruent, if I have all 3 sides, then even if I don't know anything about the angles yet, the triangles have to be congruent. And we call this the side postulate. And postulate, again, meaning it's something that we're not going to have to prove, but if you're interested in taking a little look at why that's the case, I did put a link to this in the description or in the Google Classroom. So if you want to go here and play around with this, you can see why we have to have congruent triangles if we have 3 sides. So the link to that is in the Google Classroom. If you want to play around, see why this is true. So the next one we're looking at is if we have 2 pairs of corresponding sides and the included angle. And the reason I put that in red is your angle has to be the one that's the included angle. And your included angle is your one that's included between your 2 sides. So if, for example, I know that these sides are congruent and these sides are congruent, then the included angle will be the one in between those. So if I know those 2 pairs of sides are congruent and these angles are congruent, then the triangles have to be congruent, which is why we call this the side angle side postulate. And again, if you want a closer look at why, feel free to click over here and click on side angle side, and you can play around with those side angles. It's a lot of fun. Same sort of idea with this one, except we have 2 pairs of angles and the included side. So same sort of thing with the included side. Your included side is your one between your 2 pairs of angles. So if I know these angles and say these angles are congruent, your included side would be that one. So that's why this is called the angle side angle postulate. It's nice when things are exactly what they sound like. So your angle side angle postulate is 2 angles and the side in between them. Just like this is 2 sides and the angle between them. It's nice when postulates are named exactly for what they are. And the last one we're looking at is actually a theorem. And the angle side theorem says if we have 2 pairs of angles and the non-included side, so if we have these 2 pairs of angles, and the side that's not your included side, so say we know this side, even if that's not the included side, your triangles still have to be congruent. And this is the angle side theorem, which we're going to prove when we come back. So you have that to look forward to. So now you can probably see a little bit of why this might be true just from looking at it, because we said last time that if we know 2 angles of a triangle, we automatically know the third. So boom, we know this angle. Now back to angle side angle. So it's not going to be all proof. So those 4 are the things that right now we can use to say that triangles are congruent. So to sum up, we've got side, angle, and angle, side. So if we know any of those 4, or if we can get to the point where we can say any of those 4, even if it's not something we have right away, then we can say that our triangles are congruent. So these all mean congruent triangles. So what we're doing with that today is we're looking at some pairs of triangles, and we're going to say, do we know that these triangles are congruent? And for now, you're not going to have to prove they're congruent. You're just going to have to say whether we know that they're congruent or not. We'll get to the proofs when we get back in person. So, for example, if I have these 2 triangles, we're looking for, can we say that these triangles are congruent? So we're looking for, do we have side, side, angle, angle, or angle, angle, side. Because if we can get to any of these things, then we can say our triangles are congruent. Now, if you don't have any angles, a good place to start looking is your sides. So if we know these pairs of sides, and these pairs of sides, and these pairs of sides, oh, well, that looks like side, side, side. I promise it gets a little bit trickier than this. All right, let's try one. Let's say I've got this. So is this side, 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 angle, 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 side, or none of the above? So if we're looking at this pair of triangles, we have some sides and we have the angle between them. So we have the included angle. So we have two pairs of sides and the included angle. So I'm thinking that side, angle, side. Okay, how about these ones? Now, this is kind of when I said, even if we don't know a side right away, if we can get to the point where we can say that side, we can still use it. So even if it's not drawn on here, if this side is the same in both of our triangles, then we can use it even if we don't originally have it. So now we have side, if this is the right angle, what do we know about this angle? I should probably put that in a different color because it's not a thing we had right away. So I'm going to put in red the things that we didn't have right away, but we can say based on what we know. So if we think back to where we had linear pairs, if two angles are making a straight line, they're supplementary, and if this one's 90, this one's got to be 90. So even if it's not drawn in there, we have that angle, which makes this side angle side, even if we didn't have some of that right away. So if we have it right away, or if it's something that we can get to with just what we have, then we can use it. Same sort of thing here. Even if we don't have anything besides this angle and this side right away, what do we know about some of those angles? Hopefully you say, we know those are vertical angles, Miss V, and vertical angles are congruent. So even if they're not drawn in there, these angles have to be congruent, which gives us angle, side, angle. So even if we don't have those angles drawn in there, vertical angles have to be congruent. So back from in chapter 2, that vertical angles theorem, that's still a thing. Still a thing we can use. Okay, how about this one? So same sort of thing with your vertical angles, even if we don't have them, we can say them. Is that enough? So do we have side, 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 angle, angle, or angle, angle, side? Well, we definitely don't have all three sides. Side, angle, side would be two sides and the angle in between them, so your included angle. That would be this angle. We don't have that angle, so we can't use side, angle, side. And having only one pair of angles rules both of these out. So we can't say for sure that these are congruent, so I'm going to call that not enough information. So they might be congruent, but that's not a thing that we know for sure right now with just what we have there. So you may notice the side, side angle is not a thing. And jot that down. Side, side angle is not a thing. And once we get back, we'll talk about the reason why that's not a thing. So there's a special case going on there with that. And it's not just because it's spelled something naughty if you spell it backwards. Okay. So if we're looking at this one, we have some right angles. All right angles are congruent. We have these two sides, and we have, even if they're not drawn in there, we have some vertical angles. So we have some vertical angles here. So we have angle, angle, and we don't have the side between them, but we do have one of the sides. And angle, angle, side is a thing. So side, side angle is not a thing. If we have two sides, it has to be an angle in between them, but angle, angle, side is a thing. And again, that's because as soon as we know these two angles are the same, these ones have to be. So angle, angle, side is really just angle, side, angle in disguise. Okay, let's try a few more. Let's say we got these. So we have these angles, we have these angles, and even if they're not drawn in there, we have these angles. Is angle, angle, angle a thing? Well, it's not a thing we have, and the reason it's not a thing that we have is because if we have angles that are the same, let's say we have full 60-degree angles, these triangles don't have to be congruent. And now we'll get into a little bit in a later chapter of what does have to be going on with these triangles, but I mean, you can tell just by looking at them, okay, this isn't congruent, because congruent has to be the same shape and the same size. So eventually we'll get into talking about similar triangles and what's happening if we have triangles that are the same shape but not the same size. But yeah, for right now, all we can say is not enough information to say that I can spell enough. Not enough information to say that these are congruent. Enough has an ENOUGH in it for some reason. So not enough information to say that these are congruent. Okay, because angle, angle, angle is also not a thing. Alright, let's move these. So we got these sides, we've got these angles, and even if it's not drawn in there, if this side is the same on both triangles, we can still use it. So this one we have side and a side, and this time the angle's in between them. So if the angle we have is the one in between those two sides, then that side angle side. And that's the thing. So angle in between the two sides, that's side angle side. Angle not in between the two sides, can't use that. Alright, so that's it for today as far as congruent triangles. Once we're back in person, we'll be writing some proofs with these things, but I figured that this was a better option for doing this virtually. So instead of an assignment out of the book, there is an assignment in the Google Classroom, and what you're doing with that is exactly what we were doing here. We're saying, do we know those triangles are congruent, and if so, why? So if they are congruent, then you want the reasons. So you want either angle, angle, side, angle, side, angle, side, 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 angle, side. So one of those four things. And eventually we'll get into a couple more things that are specifically going on with some right triangles, but for now we're just using those four. So we're looking for, are the triangles congruent, and if so, why? All right, I will see you next time.